High five.
Hey guys, it's Mrs. Klein.
And Mr. Creighton.
We are here with your podcast for Lesson 39, The Scientific Revolution. There's a guiding question for this lesson, just like always. The guiding question this time is, how did the scientific revolution change the way people understood the world?
And we've got a few vocabulary terms for you guys. It's geocentric theory, gravity, heliocentric theory, hypothesis, mass, rationalism, scientific method, and scientific revolution. And just to let you guys know, you can follow along in the textbook on page 555 all the way to page 563.
All right, you guys, here we go. Between 1500 and 1700, modern science emerged as a new way of gaining knowledge about the world. This major shift in thinking became known as the scientific revolution. Before this time, Europeans relied on two main sources for their understanding of nature. One was the Bible and religious teachings. The other was the work of classical thinkers, especially the philosopher Aristotle.
During the scientific revolution, scientists challenged traditional teachings about nature by asking fresh questions and answering them in new ways. In this lesson, you will learn about the origins of the scientific revolution and how it changed the way people understood the world. You will meet some of the key scientists of the period and find out about their major discoveries and inventions.
All right, you guys, here we go. Section 1, Roots of the Scientific Revolution. All right, during the Middle Ages, two major sources guided most European thinkers about the natural world. The first was the Bible, because for Christians, the Bible was the Word of God. The second source were the teachings of Aristotle, a Greek philosopher who had written about logic in the 300s BCE.
During the Renaissance, many thinkers began to question the conclusions of earlier thinkers. For example, Renaissance scholars rediscovered the cultures of ancient Greece and Rome. Arab, Christians, and Jewish scholars in the Muslim world translated many classical works and made advances of their own in fields such as medicine, astronomy, and mathematics.
Many European philosophers were influenced by Greek rationalism, which is the belief that reason or logical thought could be used to discover basic truths about the world. Renaissance thinkers also observed nature directly. The Renaissance physician Vesalius dissected corpses to test ancient ideas about the body. Trust in reason and observation became a key part of modern science.
Additionally, the Age of Exploration helped inspire the growth of science. All right, looking at section 2, Copernicus and Kepler, a new view of the universe. The scientific revolution began with the work of the Polish astronomer Nicholas Copernicus. His work led to a new view of the universe. For nearly 2,000 years, most people considered the Earth the center of the universe. According to this geocentric theory, the sun, stars, and planets, everything believed to be in the universe, traveled around a motionless Earth. Aristotle had taught this theory.
Aristotle had also taught that all heavenly bodies move in circles. Unfortunately, this belief made it difficult to explain the observed movements of planets such as Mars and Jupiter. In the 2nd century CE, Ptolemy created a complicated theory to account for this.
In the early 1500s, Copernicus tackled these issues when he used observations and mathematics to propose a very different idea. According to his heliocentric theory, Earth and the other planets travel in orbits around the Sun, which is at the center of this solar system.
Like Ptolemy, Copernicus had trouble predicting the movement of planets with perfect accuracy, but he still believed his theory was simpler and more satisfying than Ptolemy's.
However, the book convinced very few people and was even attacked by some church officials and scientists.
Then, in the early 1600s, German scientist Johannes Kepler expanded on Copernicus's theory. He wrote precise mathematical laws describing the planet's movements around the sun.
Kepler's laws coincided beautifully with the actual observations, proving that the Copernican theory was correct.
All right, moving on to Galileo and the Copernican theory. Okay, Galileo Galilei lived at the same time as Johannes Kepler. Galileo explored many questions, but he was especially interested in problems of motion.
Galileo's most notable discoveries came when he turned his curiosity towards the sky. In 1609, Galileo heard about an invention from the Netherlands, the telescope. A telescope used glass lenses to make distant objects appear much closer.
So Galileo decided to build his own telescope. And then he began studying the sky through a telescope and noticed things no one had seen before. He saw that the moon's surface was rough and uneven, and he even discovered 4 of the moons that revolve around the planet Jupiter.
To the naked eye, Venus resembles a bright star, but Galileo noticed something new. With his telescope, Galileo could see that Venus also passed through phases. Sometimes it was brightly lit, while at other times it was partially dark.
Galileo's discoveries contradicted the traditional view of the universe, and that leads to some conflict with the church.
Galileo's discoveries supported the Copernican heliocentric theory and led him into a bitter conflict with the Catholic Church.
Church officials feared that attacks on the geocentric theory could lead people to become skeptical of the Church's teachings.
Galileo refused to be silenced, and in 1632 he published a book called Dialogue on the Two Chief World Systems.
Galileo's dialogue caused an uproar. In 1633, the Pope called Galileo to Rome to face the Catholic court known as the Inquisition. At Galileo's trial, church leaders accused him of heresy and demanded that he confess his error. Initially, Galileo resisted, but eventually the court forced him to swear that the geocentric theory was true, and he was forbidden to write again about the Copernican theory.
However, the Church's opposition could not stop the spread of Galileo's ideas. Scientists across Europe read his dialogue, which helped convert many to the Copernican theory.
All right, moving on, find out a little bit about Isaac Newton and the law of gravity. Isaac Newton was born in England in 1642, the same year Galileo died. Newton was a brilliant scientist and mathematician whose greatest discovery was the law of gravity.
Newton stated the law of gravity in a simple formula. All physical objects, he said, had a force of attraction between them. The strength of the force depended on the masses of the objects and the distance between them. In 1687, Newton published a book known as Principia, or Principles, which presented the law of gravity and described 3 laws of motions. Newton's laws dramatically changed people's view of the universe.
All right, now moving on to the scientific method. A key outcome of the scientific revolution was the development of the scientific method. 2 philosophers who influenced this development were Francis Bacon and René Descartes.
Francis Bacon outlined a method of scientific investigation that depended on close observation. Descartes also saw the physical universe as obeying universal mathematical laws. These ideas helped create a new approach to science. Eventually, scientists developed this approach into the scientific method, which combines logic, mathematics, and observation into 5 basic steps.
All right. Step 1, you state a question or a problem. Number 2, you form a hypothesis. Number 3, you conduct an experiment to test the hypothesis. Number 4, you measure data and record results. And then number 5, you analyze the data to determine if your hypothesis was correct. Scientists, and you guys too, right? We still use this basic method today.
All right, finally coming to our section 6, key inventions, the microscope. Scientists use microscopes to make small objects appear much larger. The microscope was invented by Dutch lens makers in the late 1500s. In the mid-1600s, Dutchman Anton van Leeuwenhoek designed his own powerful microscope and became the first person to see bacteria.
Another important tool developed in this period was the barometer, which measures changes in the pressure of the atmosphere. Evangelista Torricelli invented the barometer in the 1640s.
Galileo likely made the first thermometer in the early 1700s. However, a German scientist, Daniel Gabriel Fahrenheit, made thermometers more accurate.
All right, you guys, in this lesson, you learned about the scientific revolution. This movement marked a major shift in the way people thought about the natural world.
All right, so looking at the roots of the scientific revolution. Several factors contributed to the birth of the scientific revolution. Renaissance thinkers questioned traditional learning and observed nature for themselves. Translations of classical texts and some new thinking exposed scholars to new ideas. Discoveries by explorers showed that accepted ideas could be wrong.
All right, Copernicus, Kepler, and Galileo. The scientific revolution began when Copernicus proposed the daring idea that the Earth and the other planets travel around the sun. Kepler built on this heliocentric theory by correctly describing the planets' orbits. Galileo's discoveries about motion and his observations of the planet supported the Copernican theory, although it brought him into conflict with the Catholic Church.
Newton, the law of gravity. Newton took all of this work a giant step forward. His law of gravity explained why planets orbited the sun. Newton also showed the same laws applied everywhere in the known universe.
All right, the scientific method. The ideas of Bacon and Descartes helped to shape the scientific method, which proved to be a powerful way of testing ideas about nature.
Key inventions. New tools such as the microscope, the barometer, and the thermometer also aided scientific progress. They helped scientists discover new facts and more accurately measure and collect data.
All right, you guys, again, how did the scientific revolution change the way people understood the world?
In a quick look at the vocabulary: geocentric theory, gravity, heliocentric theory, hypothesis, mass, rationalism, scientific method, and scientific revolution.
All right, you guys, hasta luego.
You're welcome.